All right. Yeah, thanks. Just fair warning to everybody, super nerdy. So we're going to get low. We're going to go to code. We're going to be real nerdy. I was talking to some folks earlier, and they were like, yeah, bring code. But there's a lot of suits out there, so concerned. Let's just get into it. Who am I? Now I'm the CTO at MX. We used to be called MoneyDesktop. I write code. I love writing code. I love building engineering teams. Interesting. That's interesting. But if you follow my clout profile, I am influential in Justin Bieber, unicorns, and Michael Bolton. And so if we find ourselves at a karaoke bar later, let's make it happen. This is my GitHub profile. Go check it out. We're going to talk a lot about GitHub and code and what MX does. If you're familiar with MX or if you're not familiar with MX, we partner with financial institutions, non-financial institutions, offer things that have very typically been called maybe PFM or DMM, visualizations of data. We're famous for bubble budgets, and so one of the things that I hear often is, "Oh, you guys are the bubble guys. Are you going to talk about bubbles?" Not really. We're going to talk about the meat of the code, just different ways of interacting with people in their financial lives. Because, to be frank, financial management is boring. It's a lot of work for consumers. They don't like to do it. They don't like to think about it. And so you have to find ways and reasons to pull them into the adventure and make it more significant in their lives so they're visiting it more and more often. We also have analytics tools, what some people refer to as big data. I hate the word big data because I'm an engineer. All data that doesn't fit into memory is big. So big data. We deal with a lot of that stuff. We'll talk about some of it. Some of the things that people don't know that we deal with, things like cross-platform mobile frameworks. We have a cross-platform mobile framework. You can actually see up here build servers that we've built internally where we're building Windows Phone, Windows apps, Mac builds, iOS, Android builds. We build about 300 plus white labeled apps for each of those platforms a day. So how are we setting up the infrastructure for that? We'll touch some on that. But the core of what MX houses is what has come to be called massively distributed self-coordinating systems. And so if you've kind of followed the ascent of a little-known company called Google over the last 12 years, you probably know that years ago there were the big iron companies, the big metal companies like IBM that said, hey, if you want to have a bigger experience, if you want to have a faster experience, if you acquire a bank or a credit union, you have to create bigger systems, you have to buy a bigger server. You probably know that in the last decade or so, we've decided that bigger server doesn't make sense. You have to have a way for systems to work cooperatively together to offer an experience to end users such that we call it horizontally scale. So they horizontally scale. This is, as you can see, it's labeled confidential. So these big high-level diagrams that just show the internet and machines labeled confidential. But this is a really high-level diagram of what the infrastructure at MX looks like. How we have our machine separation, our hardware segmentation, our software segmentation, how that's set up, how things come in. It doesn't really touch on really the scale of MX. It doesn't touch on how we've set up our engineering organization. And what I want to impart on you folks today kind of came in not knowing the audience. Is it builders? And so I'm going to talk a lot about engineering, setting up an engineering team, what we do at MX on the engineering team, how we scale it, and our philosophies around engineering. Day one at MX, if you're an engineer, you get 2 books. One book is a transcript of David Foster Wallace's This is Water. The other book is Zen and the Art of Motorcycle Maintenance. You would think that you'd get some book nerdy, like one of the Newth series books that's like, here's the art of computer science. The art of computer science is pretty easy to teach. Like you talk about competency. Competency is something that you need, but culture is something that's unique. And so Zen and the Art of Motorcycle Maintenance, about a culture of quality. We try and enforce this culture of quality. This is Water is one of my favorite speeches of all time, and it really starts around the premise of there's two fish swimming along. They happen to meet an older fish swimming the other way and nods at them and says, "Morning, boys, how's the water?" Two young fish swim on for a bit, and eventually one of them looks over and goes, "What the hell is water?" If you're in an engineering organization, you're in a financial institution, water is the everyday monotony of how you interact with others. When you go and ask for something for IT and be like, "Hey, I got a vendor that came in, or I have a visitor that's here," and IT says, "Okay, well, here's the form. I need first name, last name, email, and then in 6 days we will get you a Wi-Fi password." That's the water of everyday life. That's the everyday monotony of how do we teach people the empathy of those that they interact with on a daily basis. And so from an engineering perspective, engineers, I would say, don't tolerate fools very pleasantly. They oftentimes get animated. Sometimes don't know how to deal with the emotions or passions, because all day long we sit with a computer and we tell the memory what to do, and we tell the processor where to skip instructions, and it's like, sure, I'll do that. But then I got to talk to another human, and I'm like, "Hey, product manager, you don't get it. Like, this thing doesn't make sense. Those colors shouldn't overlap. It doesn't make sense." And product manager's like, "Okay, make it do it." And the engineers just they get all sometimes get all this pent-up emotion and passion. And so what we try and do with our engineering organization is introduce them to what is the water of the everyday monotony that we're going to interact with. Philosophically, if you've heard of Paul Maccready, so Paul Maccready, this is a picture of Paul Maccready. He talked about, he actually is famous for coming up with the first human-powered flying device that crossed the English Channel. And when they asked him about it, how he came up with it, he said, "Well, people have been thinking about the problem all wrong. They've been thinking about the problem because they've found that I build for a year, and then I take something out and I wreck it halfway. And then they have to build for another year, and they don't have enough time to even come up with something that's going to make it a little bit farther and a little bit farther." And so what he said was, our goal was not to come up with the flying machine, but to come up with the right process that the flying machine would yield out the other side. And so they came up with a process where they would test and document, and they'd be able to fail and fail and fail and learn and then get better. And so they eventually came up with a machine that flew, and that's really one of the things that I want to talk about today is how do we do that in software engineering, particularly in a regulated environment? We're building software that is regulated by certification after certification, organization after organization, and how do we do that? One of my favorite articles, both for the name, which is very alliterative, but also for the meat behind it, is Frequently Forgotten Fundamental Facts About Software Engineering by Robert Glass, who spent a year with the U.S. government looking at every single one of their software projects and saying, okay, what went well, what went bad, what failed, what succeeded. What he came out of this with was 60 to 80% of every software project is maintenance. So the water of everyday software is maintenance. It's how do we maintain this as it goes into tomorrow? And so at MX, we actually have this philosophy that we call continuous momentum. We're constantly trying to build momentum where tomorrow's successes build on today's. I know if you've been part of any significant software projects, you've probably heard those wonderful words of it's just a slight change. We have to make the change and then let's move it forward. Let's just put it out there. But at the end of the day, the it's just gets you caught up in that maintenance trap, because all of a sudden you're going to put another 5% of your project into maintenance. And so what we do at MX is all about taking this 60 to 80% and saying, let's drive discoverability, let's drive maintainability. How do we do that through a process that will then yield a better and better platform? And I'm watching the time, and I better get cruising. So like a lot of other institutions, one thing you'll notice that's interesting here, but that's different here, is that there's 12,500 closed pull requests, but we have a GitHub Enterprise on site, and there's constant software flowing. We call it the software river. Don't stand in our river. The software is going to continue flowing. A lot of people talk to us about how do you check all of it? How do you meet your PCI certification? How do you meet your SOC audits? How do you do all that stuff? We use a lot of tools like GitHub Enterprise to enable that. It does a significant amount for us as far as change sets and moving it in. I'll show you a few more things. Our typical change set is less than 50 lines of code. And so when it comes to the confidence that we have in the software that we release on the platform, we're very confident that there's not going to be negative side effects. In 2012, we did 254 releases. When I was at Experian, we did 2 releases a year. In 2012, here at MX, we did 254 releases. 2013, we did 1,800 releases. 2014, we did just over 2,000 releases of our platform. And 2013, we're on track to do 3,000 releases. So hopefully there's a release going out right now because we got to meet that 3,000 number. Significant amount of that comes down to what is your tooling and what's your discipline around building software? How disciplined are you when you do it? And then this is one thing that you'll see posted on the walls of MX. Style is what separates good from great. Some engineers, when they roll into MX, they're like, you're going to tell me when I have to use single quotes versus double quotes? You're going to tell me what the name of a variable has to be? You're going to tell me what the name of a file has to be? But I'm an engineer. I am greatness. But what they realize is by having a very, very strict style guide, we're actually enabling them to be more free with their creativity. We're enabling them because they don't have to make a decision on what do I call this variable. The decision's already made for them. They don't have to make a decision on what quotes do I put around this. The decision's already made for them. And then you find after 3 months, engineers say, I built more in the last 3 months than I built in the last 3 years. And then after a year, they're like, I've never been so free by being so constrained from a stylistic perspective. And so a lot of the things that you see internally at MX as you walk around the building is a lot of tracking of the code that we have. Tracking's happening all the time of what's been submitted. You can actually see here that if you submit code on our platform and you don't submit automated tests with it, we're going to reject your code. Because from day one, we've built our entire platform with automated tests across it. You have to have more than 90% coverage. If you don't have 90% coverage for the code that you submit, see you later. Right after that, it's going to do stylistic checks. It's going to check that you actually you followed the styles that we have available and that we want across our code base. That all goes back to the maintainability. We want it to be maintainable, and we don't want to make it the 68%, the 60 to 80% maintainable. We want to make it very discoverable. That means that all the code should look generically the same. It should flow in the same way. It should read in the same way. So if a new engineer comes in, they can immediately contribute to our code base. They can immediately help research a bug or troubleshoot a problem. They're not spending months and months and months ramping up. We measure not the amount of time that it takes an engineer to commit 1 commit to production, but the amount of time that it takes an engineer to get 10 commits to production. 1 commit can usually be done day 1. 10 commits on average is about 14 days in. And so discoverability of a code base is huge for everything that we're doing. The other part there is utilizing an immense amount of static code analysis. And so having people that are writing static code analyzers to be able to say, this is a good pattern, this is a bad pattern, this needs to be re-optimized in another way, rejecting that code. We're starting to move to a new level of code generation. A simple example of what we're talking about here is this was approximately a year ago. average latency latency on the platform is 320 milliseconds, touching 400 to 500 requests a second. 202 milliseconds, touching 500 to 600 requests a second, is where we started going after about 8 to 10 months. This is as of this morning. 81 milliseconds when it comes to account and transactional data. 30 milliseconds when it comes to data related to user client, white label kind of stuff. 19 milliseconds when it comes to our integrations. We have an obsessive passion about making the user experience accurate and correct, and about making the user experience positive. That's why you see us drive more and more meaning into how fast are we responding to requests. Within this graph, you can actually see that now we're hitting at about 1,000 requests a second across our platform. Hundreds of servers that are making that happen at different levels, so microservice segmentation between everything that we're doing. And a lot of people ask us, hey, like, that's really cool. You can track all of this data. You can see all this information. Like, this is really significant. But you guys live behind kind of a walled garden, and in that walled garden, you're able to dictate the entire world. We don't. In fact, every single thing that you see up here is on GitHub. Every single library that you see here is on GitHub. This is every single project that has originated at MX, and we've open sourced. We create an immense amount of software. We have over 160 repositories internally. We open source this software to the world. We work in collaboration with a lot of other institutions. There's some wild ones, like ICANN has Java class. That's probably not the best name, but it's a good Java class loading library. But then there's some really, really, really important libraries that are in here that we've open sourced and are now being used by other organizations. And that's one of the things that we wanted to focus on today is what we are doing to what we call change the face of humanity with software, because computation is, of course, what computers were made for, not what humans were made for. But when we can actually pair the human experience with computation, we can make it better for everyone, and that's one of our core drives at MX. I was going to kind of I'm running to 2 minutes, but I was going to jump into a library or two and really talk about what it does for us from a technical significance perspective. One of them is Ruby Protobuf. We're the maintainers of the protocol buffers bindings for Ruby. This is used at a lot of institutions. This is our essentially the fabric that allows us to distribute computation across hundreds of machines. And instead of going from machine to machine, being able to distribute across all of them and get a response in 30 milliseconds or 19 milliseconds, all the things that you saw up there. Underneath of this, for the technically inclined, one of the problems that we ended up solving was just around how do we have a self-coordinating system. And so there's also zero MQ bindings in this. So alternative socket layers, load balancing sockets, a completely different way of managing a cluster, managing the health of a cluster, and making a significant contribution to our success at MX. Another library that we're open sourcing is, we call it Daryl Jenks. If you're familiar with the movie Coming to America, he is the perm king of New York City. One of the things that we do is we cleanse millions and millions of transactions a day. And so what Daryl Jenks does for us is calculates permutations of strings, and we load those permutations of strings into memory and cleanse tons of data. You can actually see a directed acyclic graph here of what happens with the permutations as they go through. I'll spin through here a little bit more. Cache finders for our active remote, our distributed object system. We've recently published MX React components, which React, if you're familiar with JavaScript frameworks, React is kind of the new hotness. Go to any coffee shop, your local hipster will explain it to you. So the new hotness in JavaScript is React. We recently open sourced all of our UI components relative to React. It's really how we build a platform that is running through more than 1,000 requests a second, and I am out of time. Thanks for listening. If you have any questions, even after this, I want to get real nerdy with people, so come find me if you want to get into the weeds of any of this code.